Hi everybody, welcome to unit number 3. On unit number 3 we're going to be talking about histograms. So in this case, let's go first to the overview of what histograms are. So in this case we can see that histograms is a list of numbers, right? We use univariate quantitative data because histograms show at a glance a picture of the values of the data values. So we can see in a very easy way where majority of the data concentrates. Let's say for example we have a data set and then we have a lot of numbers here, 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 right? So this is a normal distribution. We have all our data set and we can see that majority of the data is concentrating in the middle. So how can we know that? We can do it through Instagram. So in this case, there's many types of patterns when it comes to histograms, and then we can say that also is more towards this side or on the other side. So we're going to be talking about that, right? So here we have, for example, a graphic example of how histograms work. So in this case, what we're going to be looking is at how the data distributes. So in this case, for example, we have numbers 28. We had three cases, right? Sales managers, how much they sell in terms in thousands, 32 and 18. Okay, so be very mindful that a histogram is not trying to add up or make an average out of these numbers. We're not going to use averages of these numbers. We're going to see where the data is located. So in this case, I'm not going to do 28 plus 32 plus 18. No, I won't do that. What I want to know is on a scale where they are located. So in this case, I can say, for example, there's a 28, there is a 32, and there is the 18. That means in this data set, majority of the data is concentrated within this area. Okay, so in this case, I'm going to represent a case along a line to represent these numbers. That makes it very easy to understand. Okay, so we're going to see concentrations of the different numbers now. So first of all, we need to look at the histogram and we need to look at the parts of the histogram. But now we understand how are we located the numbers. In this case, we're looking at the frequency, how often one number is repeated. So in this case, for example, if I were to look at the grades of the students in the exam, I can say that the majority of the frequency focuses on the range of 50 to 60. Okay, so here I have the number of the frequency students, how many students, and here is the grade that they have. Okay, this one we're gonna call it the x-axis and this one is gonna call it the y-axis. So that is important. You must know what are the different areas of the histogram. So in this case, we can see here ranges. Also, it can be single numbers. It can be just 10, it can be just 20, it can be just 30, but here we're using ranges because grades can go all the way from 0 to 100. So anyways, in this case, we can see in this histogram that the majority of, or the frequency, or we can see that sorry, in this case we can see that majority of the numbers are accumulating here in this area. We can see that there's very little students that are achieving the highest scores, and there's also very little students that are reaching the low scores. Okay, so again, remember, when we do histograms, we're gonna see numbers on the x-axis and numbers on the y-axis. Okay, and we're gonna see how often a number repeats. So now let's go to the difference between a bar chart and a histogram. They are not the same because many of you are going to be thinking this is just a bar chart. I know bar charts, I have seen them before. No, this one, it looks at the concentration of many numbers, right? So where are the numbers located? Where the quantity is concentrated? Look at this one. Here we have USA, India, UK, New Zealand, Japan. Okay, those are categories. That is a bar chart. When we see number ranges or numbers here on the bottom and here on the side, that means it's a histogram. So here it says whether if there's gaps, that's a bar graph, and the histogram has no gaps. Sometimes there are some bar charts that have spaces as no spaces as well, depends on the way that is displayed. So that's not a good indicator. But what's a good indicator is what we have numbers here and numbers here. So like I said, in this case, when we're looking at the bar chart, we're looking at individuals. We're not looking at where the numbers concentrate. If I were to look into this bar chart and I tell you and I ask you, very simple. So what is the number that is, what is the average or range of numbers in this specific bar chart? If you look at it, you have to quickly like I don't know. I think it will be somewhere around here, but no, it's not there. So what we have to look in here is majority of the numbers are between 200 and 300. Okay, so that is what we need to look at, right? So here is majority of numbers, and we can see it in a nutshell very, very quickly. Okay, now when we have histograms, we need to understand what is a normal distribution. For some certain reasons in nature, majority of the data is always gonna make a curve like this. Okay, there's gonna be, it is gonna be broken in the middle, and then we're gonna divide it into 4. Okay, this one's used to be smaller, this one is also used to be smaller, and I can say 90% of the data is gonna be located into this one. That is a normal distribution. So in this case, when we have a normal distribution, means all the randomness has been removed and is an ideal data set that has a lot of the numbers on the middle. So we can do calculations and we can be more accurate when we have this kind of distributions. Okay, very good. So now what can happen in here is that also we can have skew distributions. And this is happening because sometimes we have either the data goes either to one side, or also it can go into the other side. And then that's not a normal distribution. That means that there are some mistakes in there, or there's some data that is pulling too much towards one side, meaning that maybe there's too many numbers 10s, but then there's not enough 20s and 30s, and that's why it's pulling that. Sometimes it's because of a mistake, sometimes it's not. The problem with this skewness is that we cannot calculate or forecast the numbers accurately, because that means there's one number that is causing too much problem. Let's see, for example, here I have a normal distribution will be what is the age of the students in class. So let's say 18, 19, 20, 21. Okay, so if we were to put it on a scale, we can say that how many students we have of 18 years old. We have 2, well, 1, 2. Then 19, 1, 2, 3. Then 20, 21, 2, 3, 4, 5. 21, 1, 2. So we have our normal distribution in there. Okay, so in this case, if I were to ask, so what is the average, or where is majority of the data locating for majority of the students? Majority of the students are gonna be 19 to 20 years old. That is pretty much good, I can say that. But what happens when, let's say, I continue here and there's one student that has 40 years old? What's going to happen is that the data is going to go like that. So if someone comes and asks me what is the average age of a student, then I have to make the average between 20 and 40, and then that's going to be maybe somewhere around 30. Is that accurate? No, that's not accurate. So that means this number is causing a lot of trouble. This number is also called an outlier. Okay, outlier. This outlier is causing trouble. He's a troublemaker because now I cannot see the reality of this data. So what I have to do is to remove it. So what I have to do is remove it, and then I can have a normal distribution in there. Okay, Very good. So those are the problems with skewed data or outliers. Well, we already explained outliers. So now we also have other kind of distribution, which is bimodal distribution. That means that we have two bumps. Okay, two bumps. Okay. Now in this case we have two bumps. So sometimes we have data that we have large sets of data, and then we have some small bumps in here. When we have a small bump that this is not sufficient to compare it to the big one, that means that's not a bimodal, it's just a skew distribution. So we have to be very careful. So how can we know if it's really bimodal? So first of all, it has to be large enough. So it should be at least 50 to 3/4 out of the other one. Sorry, I'm gonna do it one more time. I have this one, and then it's at least 50%. 50 to 60% already of this one, right? We have it there. It's more. This is 3/4 because actually it's somewhere around 8 out of 16, so it's almost 50% is okay. So in this case, it's cohesive. It has some couple of numbers because we have 3 numbers that are cohesive in there. There's a fair gap between the two of them. There's a gap, and like I said, they represent a sample that is large enough. In this case, we can say that is a bimodal distribution, and we're gonna treat this as one group, and this is as another group. Group one and group two. We're not gonna mix them. Why? Because like I said, there's two. If we were to mix them, again, we're gonna create giving fake information or false information, as we did with the skewness, as we spoke of skewness before on the before example. Okay, very good. So now we have outliers. Outliers, I already explained it, but now let's look why outliers can, because outliers are those small numbers that do not belong to the pack. Okay, the pack is in here, majority of the data focus on this area, but there's some lost numbers that are the outliers. So what is the reason that outliers happen? First of all, it could be mistakes. Maybe, for example, one of the students told me he's 18 years old, but by accident I typed 88. So that could be an accident, no? A typo I put there, 88, and that is creating that problem. I can just remove it. If it's a mistake, I can just remove it, no problem, but I have to understand whether they meant 18, 28, 8, etc. I have to make sure that I have the right data. Okay, it can be correct, but it can be a different value. Like I said, what happens if a student is 38? The data is correct. He's 38 years old. He decided to study. He's a late bloomer, fair enough. But in this case, what we have to assess is whether I'm gonna include this number into the whole pack analysis or not. In this case, I'm not gonna use that one because it's just causing too much noise. So I'm not gonna do that, right? So that's how I'm gonna deal with that. Or alternatively, when we have these kind of numbers, what we do is how to deal with them. We are also gonna use the logarithm form of the number. Okay, so there's gonna be mathematical calculation that is called logarithm, which is pretty much another name rather than it's being called 80. When we multiply by its logarithm, it's gonna be maybe 0.7080. So what happens is that automatically all the data is gonna look as one, as well as a normal distribution when we do the logarithm. Maybe you don't understand it right now, don't worry about it, because when we do the Excel, I'm gonna show you how the logarithm transform the whole data and it looks as a normal distribution. Okay, but it's important, like I said, we can ignore it, we can ignore it, or we can just do the logarithm in order to do it. Those are the alternatives that we have on how to deal with them. Okay, so Finally, why we do histograms? It's important to do histograms because most of the time in business we're gonna have very large sets of data. When you say you have 3 or 4 or 5, then yes, you can use a bar chart because you can quickly look at it and what happens, that's no big deal. But when you have tons of information, what you have to do is very quickly, I look at the data, where it centers, where it deviates. Here there's a deviation, and what am I gonna do with that, right? Is this value accurate, or I'm gonna ignore it? Am I gonna do a logarithm? What am I gonna do, right? So in this case, I have my data concentration is in there. Is a normal distribution. Like I said, here there's some outliers, but I'm gonna ignore them. But anyways, majority of the data, 90% of the data is in this in this part. Okay, so anyways, we do data mining with this because we can very quickly look at very huge volumes of data, and then we can address what is the outcome. In this case, we have the promotions and the number of people, no? So where the promotions are, but the promotions are pretty much focusing into the 40 to 60% in this case, right? But anyways, we're gonna do the assignment of this week, and that one is gonna be more complex because we are going to do it hands-on. Once hands-on, you will understand all these histograms very easily. So don't worry much about it, but still practice and understand the concept of it. Thank you so much, and I'll see you. If you have any questions, please post them on the forum or just send them to me directly to my email. Thank you so much, and I'll see you.